Welcome back to Think Thrice Problem Solving. Today we'll be continuing our American Mathematics Competition series with a little bit of a geometry problem. So our problem states that we have 5 rectangles that are arranged into a square as shown. This is not drawn to scale, so these shapes have nothing to do with the actual size of the shapes. And we want to figure out what's the only possible configuration of these 5 rectangles where none of them overlap. So basically put in this orientation, what's the possible arrangement of these 5. So if you'd like to give this a try, go ahead and take a few seconds to pause the video and work on this on your own. Otherwise, let's go ahead and look at a solution. Okay, so we have our 5 shapes given to us, A through E, and they all have some different sizes. We notice that on our shape itself, on our square, each side consists of 2 sides of our individual rectangles. So this one has this guy and this guy, this one has this guy and this guy, this side has this guy and this guy, and this side has 2 different sides here. So if I looked at all of the different sizes up there and I arranged them, it must be true that for 4 different sets of those numbers, they add up to the same number. So let's go ahead and look at what I mean there. So if I was to list out these, so I have 1, 6, 2, 4, 5, 6, 2, 7, and 2, 3. Let's arrange those in numerical order. So I have 1, 1, I have 3 2s, I have 1, 3, 1, 4, 1, 5, 2 6s, and 1 7. So hopefully that adds up to 10 numbers. That is. Okay, so what we have here, it must be that 4 combinations of these numbers add up to the same number. So let's just take a look at these. I'm probably going to have 4 higher numbers and 4 lower numbers. If I try 7, so let's try them adding up to 7. So I would need a 1 and a 6 together. I could use a 2 and a 5. I don't have any other 5s, so I would have to go a 3 to a 4. And we notice that I only have 3 combinations, so it's definitely not going to be 7. What about 9? Would 9 work? So we go up to 9. So if I did that, I would have to have a 7 with a 2. I would have to have a 6 with a 3. And a 4 with a 5. And once again, I only have 3 combinations. So 9 definitely won't work. And as you guessed, it's going to turn out that each side is going to be 8. I can put that 1 with a 7. I could put a 2 with a 6. I could put another 2 with a 6. And I could put a 3 with a 5. So if this is actually our solution, then whatever's left over better be one of our rectangles. So I'm left over with a 2 by 4. So that means that our inner one must be a 2 by 4 rectangle. Okay, so we've identified where the 2 by 4 is. We don't really know the arrangement quite yet. So let's go ahead and pull our shape up here and take another look at it. So this is a square. So looking at this shape here, so if I have a 7, so one of these must be 2 by 7. So let's just call this one at the top a 2 by 7. So if this is 2 by 7, then that means that this right here must be 1, because the sum of my side lengths is equal to 8. The only size, so I've already used my 2 by 7, the only size remaining is a 1 by 6, so that must be a 1, and this must be a 6. So by deduction, I can see that this side must be an 8 length. My 2 by 4 is already going to be in the middle, so the only side with length 2 is my 2 by 3. So that means that this guy is going to be 2, and this is 3, which means this remaining side must be 5. And look at that, this side ends up being 6. And then if we look at our orientation of our inner square, so I have 5 plus x plus 1 is equal to 8. That means x has to be 2. So that's going to leave us with a 4 right there. So we can now see that we have the given blocks. So this is my 2x4 block, this is my 2x7 block, my 1x6 block, my 2x3 block, and my 5x6 block, with the sides oriented as shown. Okay, so I hope you enjoyed this little problem. Not too tricky, but kind of an interesting way to think about a problem. If you have any of your own problems that you'd like me to work, please feel free to submit them via email. As you're working on problems yourself, if you get stuck, make sure you're thinking thrice. And if you enjoyed this video, please like and subscribe. Thanks.